0, pen's not working. 0, negative 11, why? I think Burke's going to tell me, because Burke's the one that told me it was 0, negative 11. Why, Burke? You could look at it from a Q and P perspective, because this is really 4x, and then there's nothing for P, and then Q is out at negative 11. Or you could remember, yeah, that's what I'd do. So here, 0, negative 11. The equation of the axis of symmetry, if that's the vertex, the axis of symmetry goes right through it. That's where x equals what? 0. What's the range? X or y values? Y must be greater than or equal to what? Negative 11. Is it a max or a min? It's a min is negative 11 at x equals 0. And I believe I just said graph it. No, you had to have some points, yeah? So, 4 stretches 4. So when I go over 1 to 1, how far up do I need to go? 4. So it's at 1, negative 7. And then what's over here at negative 7? Negative 1, negative 7. And then... Nice. This guy, what's the vertex? 3, 5, because it's got to be reversed. 1, 2, 3, 5. The equation of the axis of symmetry, x equals what? 3. What's the range? Y is less than. Why is it less than? Because it's a max, because it's a negative. Well done, everybody who got that. Y is less than or equal to 5. Max or min, it's a max equals 5 at x equals 3. Now, it goes downwards. Is there any stretch? No, so it's over 1, down 1. So what's that point? 2, 4. And then what's the other point over here that's got the same y value? 4, 4. And then boo-doo-boo-doo-boo-doo-boo. Sad parabola. Oh, yuck, barf. What's the vertex? Negative 2, negative 5. Equation, x equals negative 2. Range, less than or equal to, less than because it's negative. It's a max of negative 5 at x equals negative 2. And then a couple more points. This one's very tricky. When I go from here, which is negative 2, negative 5, and I go 1 to the right, how far down should I go? A half. That's a pain, right? So what if I go 2 to the right? How far down should I go? 2. So that is 0, negative 7. And what's going to be over here? Even if you didn't do it this way, what would be here? Negative 4, negative 7. Gouda? Great. Graph them. Graph that one red, graph that one blue. Follow along, make sure you do it right. Vertex, 1, 2, 3, 4, 1, 2. Negative 4, 2. What did I say, 5 other points?
Yeah.
That's a pain. Over 1, down 1, over 1, down 1, over 2, down, 1, 2, 3, 4. 1, 2, 3, 4. 5 points in total or 5 others? 5 total. So the vertex and 2 more. All right. Oh, I just did that totally backwards. Shut up. Not you guys, me. And now the computer's frozen to show my mistake extra long. I was just seeing who was paying attention. Not true. I totally screwed up. 2, 3, 4, 1. 4, 1. Stretch of 2. So over 1 up 2. Over 1 up 2. Over 2 up 8. 4, 6, 8. So it's
Is it up 8 from the last point or up 8 from the
up 8 from the beginning. So it's going to be up 6 from the next point. 1, 2, 3, 4, 5, 6. Okay? Red. 1, 2, 3, 4. 1, 2. It's negative, so down. Right 2, down 2. Right 2, down 2. Right 4 should be down 16, but it's only going to be down 8. 2, 4, 6, 8. 1, 2, 3, 4. 1, 2, 3, 4. And then the blue one. 1, 1. And it's going to be negative 3. So over 1, down 1, 2, 3. Over 1, down 3. Over 2, down 12. It's going to go off the graph. So, of course, you were checking your work and make sure your parabolas look like mine. So I hope you're starting to notice something. As the A value increases, the parabola narrows. As the A value decreases into fractions, the parabola opens up. Okay? Any questions about 5 and 6? Excellent. And finally, 7 and 8. I don't know why there's that big space there. This one's very tricky. It's 1/3, right? So how far over should I go? 1, 2, or 3 to do my next point? 3. And when I go over 3, how far should I go up? 3, not 9. 1/3 of 9. 1, 2, 3. And then where should my next point go? 6 over. And instead of going up 36, how far should I go up? 12. So 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. And then 6. 1, 2, 3, 4, 5, 6. So it's this one. Everybody good? Okay. Something that I would like to make abundantly clear to you right now. I will never dock you marks if your parabola isn't pretty. You understand what I'm saying? That's why I need you to show me the points, right? Kids in the past have gone like this. There's my parabola. And then they're like, oh, Mr. Myers, I drew the parabola right there. Why didn't I get any marks for it? Well, because I can draw parabolas all over the page too. Ooh, I can put a sideways one on if I want. Ooh. I need to see some points, right? I don't care if your curve is perfect, but I do need to see some points, all right? And I'd like it to be semi-curvy. Don't do that. Don't try to tell me this is a parabola. Okay? Everybody cool? That was 99, yeah? Okay. Let's take a break from quadratics, and let's have a look at your, don't look at that. That's a grade 10's, check my marks. Let's have a look at your cumulative examination. If you didn't write this, you've had weeks to do it. Well, days. Remember, I haven't changed check my mark yet, so don't start asking. And remember, you got to bring this back to me. There you go, partner. See what I did there? Because he's a cowboy. I call it. Oh, it's a cow. Oh, it's a bull. So it's an actual cow. Bert's way over there. I don't want to walk over there yet. Only if you want it to be right. I just was wondering if it was the size. All right. You needn't check the answers, Megan. I'm about to go over it. Damn it. Damn it! All right. At the top here, remind me if you remember, what does vertex form look like? If you don't remember what vertex form looks like, you could flip back one page and find out. A. Yes? Agreed? Now, if we had numbers there, it would look like this, right? Yes? Everyone agrees? Right? Now, if I expand this, what do I get? Does everybody see what I did to get from the first yellow to the second yellow? Everybody see? Yeah? Okay, now please notice the next thing I'm going to highlight in yellow. Isn't that the exact same form as that? So if you can mess this around to get to here, could you graph that super easily? Could you? Sure. If it looked like this, you could find the vertex and you would know the stretch, wouldn't you? Okay. So what have we learned in this unit that makes something like that look like that? What are the things that we can do to equations in this unit? Starts with a C. Ends with an E. Has complete the square in the middle of it. Yes, you would complete the square. Nice. Way to go, Rav! You Rav is Ruby's neck. So, we're going to complete that square, aren't we? How would I? So, if I have this, which is standard form, I can complete the square to get vertex form. So that's one option for me. So let's do that. Okay? How do I complete the square? This is what I'm starting with. Y equals x squared minus 6x plus 4. Now, which part of this do we need to worry about to complete the square? A, B, or C, or some combination of them? B and C is to complete the square part? I'm asking you. It's here or is it here? Yeah, it's B and C that are going to change, isn't it? Right? Now here's something I like to do. I know that this is the business part of this, correct? And I know that this part isn't very important right now, right? So I'm going to go ahead and I'm going to move that out of the way. So I get y minus 4 equals x squared minus 6x. Now I can complete the square here, yes? And what do? Half of 6, which is, and then do what with it? Square it to get positive 9. Now I factor this side, yes? Yes! I just added 9 here. Is this equal anymore? So what do I got to add over here? Plus 9. So now I have y what? Plus 5 equals x minus 3 squared. Am I very close to vertex form? What's the only thing left to do to get vertex form? Move the 5. Minus 5. Could you graph this in about 2 seconds? Sure. What's the vertex? 3, negative 5. Any stretch? Nope. So I go over 3, down negative 5. Go over 1, up 1, over 1, up 1, over 2, up 4. Over 2, up 4. And graph it. Everybody cool? So it's something we learned back at the beginning. We can apply it to graphing. Is everybody good? Okay. Now, as always, looking at that right now, could you complete the square? You could, couldn't you? Because you can factor out that 2, that'll be even, it would be easy to complete the square there, yes? Everyone agree? Now that you've seen completing the square, you know how to do it, I'm going to give you a little gift. Okay? Standard form has a shortcut to the vertex x coordinate. Okay? Vx. That's the x coordinate of the vertex. And that shortcut is this. The vertex x always equals b over 2. It's b over 2a. So looking here, what is b and a? Where's b? 8. Where's a? 2. So knowing what you know now, can you find the vertex x-axis? The vertex x-coordinate, I mean. What is it? It's 8 over 2 times 2, which is 8 over 4, which is 2. Yes? Everyone's cool? You all did it in your head. That's fine. I just like to show you the work. Is that an x coordinate or a y coordinate? X coordinate, yes? So that means that 2 is an x value, isn't it? Can we do something with x values? What? We know up here that this is what y equals, right? So that must mean that y equals 2. What's x? 2 squared plus 8. What's x? 2 plus 11, right? What's 2 squared? 4. Okay. What's... Oh, I forgot a negative in there, didn't I? Yeah, I did. What's this? 2 squared is? 4 times 2 is? 8 times 2 is? Plus 11, right? But there's a negative in there. It's negative b. Sorry. So this is really what? This is really what? -2. So this is really what? -16. So what's my y value? What's 8 minus 16? -8. What's -8 plus 11? 3. So if my x is -2 and my y is 3, do I have my vertex? Which is where? -2 up 3, right? And now, can you graph it? Look carefully. I'm going to do 2 little highlight things in a second if you don't figure it out. Talk to your neighbor and see if you can tell me where the next point is going to be. All parabolas follow what pattern? He waited patiently. All parabolas follow what pattern? Over 1, up 1, yes? Unless there's a stretch, yes? What letter represents the stretch? Don't I have an A? So what's the stretch? 2. So when I go over 1, how far up do I need to go? 2. So that point right there is -1 what? 5. And what's this point right here? -3, 5. And now I can graph it. Everybody cool? So let's talk about what we learned about standard form. 1, we can complete the square. Complete the square. And that gets us vertex form. Second thing we learned. The vertex x-axis equals what? -b over 2a. Once I have that, once I have an x, what can I do? I can sub in to get y. And there's one other thing I can get here, right from this. I can get the y-intercept. Y. What is every single y-intercept? 0y, correct? Is that an x-coordinate? So where can that go? In for x, yes? So y equals a, not x anymore, what is it? 0 squared, plus b, not x anymore, what is it? 0 plus c. What's 0 squared? Times a? 0. Plus b times 0? 0. So what happens to these two terms? They're gone. What's left? C. So the y-intercept equals C. When? Only in standard form. Everybody cool? Yeah? Everyone is good? There's everything you just wrote. This is your homework for tonight. It's only 4 questions because it's Halloween. I want this in this form, which means what? Can you use the shortcut? No, because if I was only graphing, could I use the shortcut? Yes, but I actually want it in that form. Everybody cool? No, don't bother sketching the graph. I believe you guys on the graph. But here's what it should look like. The shape, like the equation, and then I want vertex, tell me what it is, and y-intercept, tell me what it is. If you just tell me that, I'm happy. Everybody cool? 4 questions. That's it for Halloween night.